Hello friends, welcome to our channel. Let's have a look at a newly appeared problem, problem 3676, Count Bowl Subarrays. In this video, we are going to address this problem using a very typical technique called monotonic stack. So basically, we are going to maintain a local decreasing stack. So this is our overall strategy. So let me first go over the problem statement. So basically, we are given an integer array called nums. So here with distinct elements. So this assumption is very important. Actually, it determines the way we count or the way we use monotonic stack in the monotonic stack condition. So here a subarray is called bowl if the two ends, the smaller one, is strictly larger than the middle elements. So that's the two items. Because of this constraint, the length is at least 3, right? So we want to return the number of bowl subarrays in nums. So if you look at the 3 examples, so this one is special because there's 0, right? We are not going to look at the details. Well, for the first two, actually, they list the valid bowl subarrays, right? So here, if you look at the length, it can be as long as 10 to the power 5th, right? And also, it has a lower bound that is 3 in order to make the problem valid, right? So the element is all the element is positive, right? Or positives. So the numbers distinct element, it emphasizes it again, right? So here our main idea is like this. So we are going to do a for loop, right? So at each index, index r, so we are going to check how many valid bowl subarrays ending there, right? So that's basically the strategy. Then we just sum with respect to r, then we get the result. So if you have practiced quite a lot about monotonic stack, so this problem should be rather straightforward. So here, let me first write the code, and then we explain the logic in between, and later we do some prints so that you can know the details. So first, I'm going to initialize a result variable. So this is the counting variable, whose final state is what we want to return. And then I'm going to initialize a stack, right? And then we are going to do the for loop, right? So because we are going to track the index, I'm going to use ry in enumerate, right? So nums. So here, what we want to do. So let's look at the monotonic stack condition. Also notice this distinct elements, right? So while stack, and so notice the stack is going to store indices, not the numbers directly, right? So if the top element in the stack, that is stack -1, because this is the add condition. If stack is not empty, we can always retrieve the last element. If the corresponding element is strictly smaller than y, right? So then this y can potentially be a red point corresponding to the r in this definition, right? So what do we do? So we do stack pop, right? And then so after this, so what we are going to do is we check. So because the stack is monotonic decreasing, so from this L to this R, so if you have some elements previously popped out, it should be smaller than L, right? So what we want to check, if r minus L plus 1 is greater than or equal to 3. This, from this L to the current R, it forms a valid bowl subarray. We are going to count it by 1. So we are using increment, right? So this is the one. Then after the val, then all the elements will be greater than or equal to y. So in this case, so we also want to check if the current stat is still not empty, and then r minus the stack -1, because this element, so after you exit this while loop, either stack is empty or this condition is not true. If this condition is not true, it means the top element corresponding to a element which is greater than or equal to y. So now y is the smaller of these two ends, right? So previously here when you do the check, so y is the larger. So in this case, so we are going to do this. So if this is greater than or equal to 3, then we're going to increment the result again by 1, right? So afterwards, what you do, we stack append the current index. So you can, why we should do this line? So logically or just from the code structure, you from both the two perspectives, you can notice this. Because if you are at the first element, the stack is empty, right? So you need to add the index into the stack. So that's the full code. So you can return the result. Let me run it. So it passes all the cases. Now let's submit for generic case. It's moving slow. Yeah, it passes all the cases. So now what we want to do is this. So at each R, so we want to see we look at how many valid subarrays it contributes. Therefore, we can do this such print. So, entering step, say R, then the information will be the result is like this, and then we have what? Let's just have this result. So also we can do a stack if you like. And then, so here, what we want to do is this. Exiting this step, so the result and the stack. So you can check the difference of the result, right? So now let's print out this thing. So if you look at the first example, so ending at so this one. So let's see, you have 2, 3, 1, 4, and 5, 3, 1, 4, right? So here you see 0, 0, 0. Then at the last step you have 2, right? So this 2 actually corresponding, to this one and this one, right? So in other words, only this 4 can be used at the right hand. Now let's also look at example 2, right? So here you have 5, 1, 2. So when you add 2, index is 2, right? At the index 2, after you exiting, so your result from 0 to 1, right? So also they can have 1 ending at 3, right? So that's index 3. When you exit index 3, the increment of the result will be 1. So when you exit step 3, the increment from 1 to 2 is 1, right? And then lastly, you will have a red point at 4, right? 0, 1, 2, 3, 4. The index is also 4. So if you exit, so the increment of the result variable is from 2 to 3, right? So the last one, because you don't have, right? So always 0. So because this one is is already monotonically decreasing. So you can use this one as a hint for the technique you're going to use. So with that said, I guess that's it for the current video. You are welcome to check out our playlist for monotonic stack or other playlists in our channel. Thank you for watching.